Hey guys, all right, so I know that you are sick and tired of taking Cornell notes, so I'm going to make this short and sweet. I'm going to see if I can get this thing done in under 4 minutes. Okay, so we're talking about projectile calculations. So let me zoom in so I can write this. Okay, so my topic is projectile calculations. This is the stuff that takes the longest. Projectile calculations. And my essential question, oh, that doesn't look like a Q. My essential question is how can I use motion equations to analyze projectile motion? All right, how can I use motion equations to analyze projectile motion? Okay, well, here's what's really important, guys. We know that there's two different parts to projectile motion. Okay, so anytime something does that, we know that there is a horizontal component and there's also a vertical component. So we are going to separate those out for our motion equations. So we're going to have a horizontal side and we're also going to have a vertical side. Now here's the nice thing. There are no new equations here. These are all equations that we've already used. So because horizontal is, man, that's bad handwriting. Okay, let's make that look better. So because horizontal motion is constant velocity, we're going to go back to the very first unit, unit 1 here, and we are going to use the simplest equation that we've had so far. And we're going to use this. V equals delta x over delta t. Okay, now I'm going to rearrange that just a little bit because I think that in this form sometimes it can be hard to use. And so I'm going to rearrange it by cross multiplying, and I'm going to change this to delta x equals v times delta t. So that right there, guys, that's the one that I'm going to write on the board, okay? That's important. Now, let's go ahead and identify delta x is going to be not just the distance, but the horizontal distance traveled. And delta x is going to be in meters. Okay? V is not just velocity, my bad. Horizontal velocity. Now notice there's no VI or VF here because the velocity is constant. It always stays the same. That's going to be in meters per second. And then delta t is time falling. And that's going to be in seconds. Okay. Now, vertical over here. So there you go. You've got all your horizontal. Take a second to write that down. Vertical, all right. Here's what we're going to use. We're going to use yi equals 4.9 times delta t squared. Now, I know that before we used this part here, we used minus vi delta t. Well, we know that vi is always 0, okay? And so since vi is always 0, let's just erase this. Let's just get rid of it. I'm tired of looking at it. That thing's gone now, okay? We're leaving that off so it's simpler. Okay, so now this one's even simpler than the horizontal because there's only 2 variables, all right? So yi is height. That's always measured in meters. And delta t is time falling. And that's always in seconds. Okay? Now, if we look at a diagram, okay? So if I were to draw, a situation like this, and then I drew the trajectory. So let's say that something flew like that, okay? Well, if we had this, we should be able to label, okay, yi delta x, and then the initial velocity that way, that's your v, okay, and then time is delta t. Now, the most important thing here, okay, and what I really, really, really want all of us to remember, okay, is this next thing that I'm going to say. So if we look back up here, sorry, I'm scrolling around a lot. If we look at the two, and we say, okay, well, what do they have in common? Well, the big thing that they both have in common is delta t, okay? So delta t is the link from one equation to the other, all right? So I'm going to write that really big here. Delta t is the link from one equation to the other. And so I'm not going to do a big long example here, but I want to like kind of give you a little bit of a hint here. So let's say that they gave, so my given, let's say they gave me delta x and they gave me v, okay? And they asked for yi. Well, if I look up here and I know that these are my three variables, I know that there's no equation that has delta x, v, and yi, okay? So this equation doesn't have delta x, v, and yi, and this equation doesn't have delta x, v, and yi. So what I have to do is I have to, all right, so my method here is going to be to use the horizontal equation to get delta x. Then I'm going to plug in, I don't mean delta x, I mean, Mr. McSparron, I mean delta t. Then plug in delta t to vertical equation to get yi. So very often they're going to make you use both equations, and it's really super important that we see that if we're going to use both equations, delta t is the thing that links the two equations together. So if you're ever unsure of where to start off by finding delta t. That's a great starting point, is to make sure that you know delta t. Okay, guys, that's it. Let's see how I did.